Hi everyone, Robin here, going to look at thinking ahead. This is predominantly aimed at the OCR A-Level Computer Science spec, but is appropriate for the other exam boards. And the other big thing I want you to really think about is how it relates to the NEA and gaining marks within that. So whenever we start a new project, so your NEA project, it's really essential that you think that through and you get a lot of marks for the justification of how you've thought that through. So in other words, you think about where is data coming from, what happens to that data, and then where does that data go to. In other words, we're thinking about the inputs and then the outputs of that situation. So what do I want to achieve? I want to have a display, I want to have a graph output, whatever it might be. What data am I going to input to create that? And then we can sort of separate it out into three main sections, can't we? What data is going in, what happens to that data, and what data goes out. This is something that is often overlooked again by students, and the justification for this, the decision points for this, are where the marks are in the NEA. So why have you chosen those particular inputs? Because obviously if you don't include all the inputs you need, you aren't going to be able to solve the problem. So when we think about these inputs, what actually are they? Is it, say if it's a game, is it arrow keys? Is it a click on the screen? Is it a particular button that's being pressed on the keyboard? Where's that coming from? And obviously that's going to impact all sorts of different things. The gameplay is going to impact sort of the usage of it, how difficult or easy it is to use. You want to consider the age of your user. So will a small child still be able to use the system, or is it aimed at perhaps older people? Is there sort of accessibility considerations to be made here? Again, all of those things on the surface, to think about the inputs is very simplistic. But actually, the more you think about it, it's not. It's really quite an involved process, and you're thinking about the impact that that has. And again, you justify this in your NEA. Once we've thought about the inputs, we also want to think about the outputs. What do we want to happen? What visuals are we going to show? What data is going to be shown? What data is going to be sort of available? In what formats is that going to appear? And again, this will impact on the complexity of the situation, the system that you're in. So again, if it's a game, is the output really high intense graphics? Therefore, is that going to impact on the device that's being used to demonstrate that? Is that going to impact on the time, the complexity to build the system? Or is it going to be quite simplistic and therefore can be made more manageable, but therefore is going to perhaps be less appealing to the user in some way? So you have to consider that and think about what decisions are going to be made about that. How much time have you got to make the process? Where are you going to dedicate your resources accordingly? Obviously now what we've got is we've got a set of inputs and then we've got a set of outputs. So for example, if this was a racing car game, we were going to use the arrow keys. That's going to make the car move, and therefore the output needs to show that that car moves in some way based on the input that's being used. In other words, we've got a middle point missing where we actually make that happen. And again, by doing that, we separated it out into clearer and easier to understand chunks, and therefore we can think about the problem correctly and making sure that those inputs communicate correctly with the required outputs. Okay, simple example of this would be a noughts and crosses game. And if we think about this, on the surface, it's an incredibly simplistic game, something that I'm sure you played many, many times. But that if you think about it in a simple sense, where we've just got a piece of paper, well, the first thing we always do is draw out the layout, isn't it? In other words, what the actual user is going to sort of experience and know where they're up to. What we then need to do is indicate in some way where a go has been taken place. So how are we going to identify this area of the board? We need to think about that, don't we? It's either going to be a button pressed by the mouse onto that particular area of the screen, or this is going to be represented perhaps by a series of letters on the keyboard, and therefore if you think about the keyboard, the Q would represent this one, the W would represent this one, and the E might represent this one. You get the idea. So we want to think about that and think about how is that going to impact on the gameplay, and also once one of the choices has been made, how is it going to be represented? So you can see that with a simple piece of paper, we represent the X or the cross for one person's go, and then the 0 for the other person. And obviously there are rules around this about taking turns. We've got to include that within the outputs. So it's really important we think about all of those problems before we set off. So a way we can approach this to make it easier to understand is to think about these sort of set of rules. So what data types are we going to allow? What validation rules are we going to have? What preconditions are we going to have, etc. So if we look at the data types first of all, if we're thinking about noughts and crosses, it's really going to be one or the other. And therefore we might represent that with an integer, so a 1 being a representation of the cross, a 2 being a representation of the naught. It could be that we do it in a sort of a more Boolean sense, so it's true or false, so true being the x or the cross, false being the naught. How do we want to apply that? How do we want to have that rule happening? And again, we've got to consider our maximum minimums of this. If we're going to use numbers to represent the go, we've got to make sure that there's a limit to that. You can't therefore have multiple sort of noughts and crosses on the same screen, for example. Okay, another key aspect of data types is understanding their importance and why they matter so much. When a compiler builds the machine code from the code you've written, the program code, what it does is it uses an abstract syntax tree. In other words, it's representing out the different aspects of the system. So in other words, if we've got a syntax tree here, I'll very briefly describe this, we'd need to know that there was an addition calculation happening. We would need to know that there was a number on this side and a number on this side, and because of that, it would then be able to read that as 4 plus 3, and therefore would know that it could then add to 7. What's actually happened here, though, is we've needed to state that therefore that and that are both integers. If you think about this in a different sense, if that was written instead as a character, that it wouldn't make sense, would it, to add them together? So as you can see here, 3 plus 3 in that sense would give you an error, wouldn't it? As humans, we can translate that in our mind, can't we? We can do that very easily, but a computer can't. It will have preset that as a set of characters, and therefore the binary number is being used to represent characters, not a number. So in other words, if you think that we're using binary numbers, so I'm just going to write a random one out here, that binary number there could be representing a character, or it could be representing a number. You could do both, but the computer needs to know which it is. And therefore, we're going to create a conflict within the system if that isn't clear, if we start to contradict. And this is why we need to convert. So in other words, you've possibly done this in Python, you needed to convert it to an integer. In other words, we're making sure that the computer knows that this binary number now is dealing with a number, not with a character of some form. What we also need to consider is the validation. And again, this is something that's in the NEA and it's incredibly important to talk about. How are we going to make sure the user cannot make errors? And again, can we design the user interface in a way that will help to prevent those errors? For example, things like drop-down menus are really useful because they only limit the user to have a certain number of choices, and therefore sort of present that in a clear and easy to use way. The other thing with validation is making sure that we're following rules and that we're applying those rules. So it might be that we have maximum and minimum values, or that we're going to use things like special characters within a password. The way that we control our data is really important. We want to think about the structure of it. And again, the way if we choose to put data into a stack or a queue or into an array is going to affect our usage of it. And again, if we're going to store something, say, in a database, that's going to impact on the usage of it, the way that we search for the data, the way that we sort that data. They're all going to be affected in different ways. So we need to decide that up front and think about what is appropriate for the situation we're in. We want to think about the different arguments that we have, and therefore what kind of rules are we allowing, what actions can we carry out. In other words, a simple example of this would be in a bank account. If you're going to remove money, there must be the money in the bank account first. Otherwise, we're just going to allow free money to be taken out, aren't we? And therefore, again, once money's been removed, the value in the account must change appropriately to show that money being removed. Other preconditions we have, if you remember our noughts and crosses game, said about this as a rule, that it has to always start with that layout. In other words, the 3x3 layout. And again, we've got various rules about this, that if you have crosses going across all three, you therefore have achieved a win, and therefore that should be recognised by the system. We want to think about where our data is coming from. So is it coming from a sensor? Is it coming from the user? Is it coming from a sort of a countdown clock in some way? Where's that coming from and how's that going to be used? How's that going to control the system? We need to think about the outputs that are happening. So how is it going to be displayed? Is it going to be updating a graph? Is it updating an image? Is it a noise value? What's happening and how's that going to be interacted with so that the user can fully understand the system? What we also want to do is think about where we can reuse components. So again, if we're thinking about the different sub-procedures that are happening, we can use functions as well within that, but also we can use library modules as well. And in other words, it's saving us time. So where, first of all, with procedures and functions, can we split down that problem into smaller sections? Can we then divide those out across multiple programmers? Or we can just approach one procedure at a time and therefore kind of work our way along to solving the problem in a more manageable way. Python, for example, has things like Pygame or NumPy as libraries that we can use. In other words, somebody else has already pre-written code to help you out. Tkinter is another example where they've worked out how to make a button, and therefore we don't need to solve that problem again. We can just use their code to do it. This does come with benefits of it being much quicker to do. You can also argue it comes with some limitations, that if there are sort of issues with the way that library's working, or it might be a bit cumbersome or slow or whatever it might be, that then you do inherit those problems as well. But ultimately should save you time because you're not having to rewrite the code again and again and again. What we wanted to do is think about anything that's frequently used. And again, if we can therefore simplify that. So for example, if you think about, say, your computer, if you open up a sort of a software such as like a word processing thing, you'll often have things like file, edit, sort of maybe a modify or something kind of insert type menu, and they're the things that you're using frequently. And again, if you think of, say, something like Microsoft Word, for example, they even have simplified images, don't they, to represent the things you're going to do frequently. So in other words, the changing of the font color or kind of inserting a picture, they're all easy to find and easy to do and easy to represent, and therefore we're making it more and more usable for us. And like I said, with the NEA, you need to think about how you're making this better for the user, how you're justifying that and really helping them to understand it. And you have to explain your decision, and this is where all the marks are. Why have you made that choice to use that particular image to represent that particular thing and in that particular location? So I want the user to be able to save their work really easily. So I'll put a save icon in the top left-hand corner where they'll immediately see it. Makes it much, much easier for them to understand. Again, you may incorporate some third-party tools within your system. It might be something like Google Maps, for example. It could be that you're going to use some sort of like two-factor authentication. Again, you're helping to bolster that within your system. And obviously, you must explain this and talk about why you've chosen that. What is it about that third-party tool that makes it useful? Obviously, from our point of view, from an NEA point of view, we want to be cautious of this because obviously what would be then happening is we aren't writing the code for those aspects. So it might be something that you maybe do a little bit just to represent something or to show something, but you wouldn't make it the main part of your system. Okay, well, thank you for watching. I hope you found that useful. If you've got any questions about this, please do ask in the comments below. Otherwise, I'll hopefully see you again. Thanks a lot. Bye.